Hello guys, how are we doing today? So we have a nice little problem for you and we'll start immediately. Okay, randomly choose a XYZ a coordinate on the unit sphere, not inside. Okay, what is the variance of the Z coordinate? We have to figure out the variance of the Z coordinate. Now this goes back to Galileo, no, not Galileo, even older than that, the Eureka guy. I forgot the Eureka guy name. Wait, let me check. What is the name of the Eureka guy? Uh, I know you guys know, but I don't. Archimedes, right? So this goes back to the Archimedes. So Archimedes was fascinated with this. So Archimedes is famous for Eureka and the water and displacement, all those things. But he liked the most, and I think it was on his grave or something, that if you have a sphere and if you have a cylinder which goes around the sphere, so then the area of this part in the on the sphere, it doesn't matter where you cut the sphere from, you can cut it anywhere to, and area of this cylinder which encompasses the sphere is always the same. Curved area of the cylinder is same. So he proved that. It's very easy to prove it, and you should know it. This is like a 2500-year-old problem. Okay, so and Archimedes really loved this problem. So this goes back to this. So how does this help? So the thing is, we have to figure out the distribution of Z coordinate. Okay, so so you take a sphere, and to figure out the distribution of Z coordinate, okay, so let's take this is the Z axis, and we have this as x and y, x cross, no, so then this is the x cross y, xy, and this is the Z axis, right? So for the distribution, you basically have to do the area thing. Okay, and as Archimedes said, area of this strip of dz length and this strip of dz length and this strip of dz length, they are all the same, right? So so the point is that Z is uniformly distributed on the unit circle, and you can check it via the code also, and Archimedes proved it. So we'll move forward. So Z is a uniform distributed function between -1 and 1. Z belongs to this, and it is uniformly distributed. And what is the probability distribution function? And in case of uniform distributed function, the variance is b minus a square divided by 12. So the variance is 4 by 12, 1 by 3. Okay, and we can prove this also. So let's prove this. So first, let's calculate the PDF of uniform distributed function. This PDF is 1 by b minus a. Why? Because integration of probability distributed function into dz is from -1 to 1 is from any variable, let's say x. Any variable is x, other specific variable is z. So a to b. So this has to be 1, right? So PDF, it's uniform. So PDF is a constant, and so PDF into b minus a equals to 1. So PDF is 1 minus b minus a. Okay, and we know the mean. So these formulas you should remember, including this. So mean is obviously b plus a by 2 for uniform, right? I don't need to explain why the mean is mean, right? We all know why mean is mean. Okay, and then comes the variance. So variance is if I remember correctly, expected value of x square minus square of the mean, and so expected value of x square is integration of PDF x square dx, right? Yes, that's right. And minus mean, we already know mean. So so let's say ex square is equals to this. So this is nothing but PDF is constant 1 by b minus a, integration of x square is 1 by 3 into x cube. X cube is b cube minus a cube. Okay, so we are good to go here. So we know the expected value of x square. So let's prove this now. So this is 1 by 3 and b cube minus a cube. We'll take out b minus b square plus ab plus a square minus square of the mean. So b square plus a square plus 2ab divided by 4. And let's solve this. So b square by 12 plus a square by 12 minus ab by 1 by 3 minus 1 by 2 is 1 by 6. And let's do this. So we have this as b minus a square divided by 12. Yes, so we proved it. So the variance is 3. So this is a two-parter, and the two parts are basically proving that x and y, so z is a uniformly distributed function, and the variance for a uniform distributed function is b minus a square by 12 square. How do we get that? First we find the PDF, and then we found the mean, then we found the ex square, and then we found the variance, and then we found the 4. It would be good to remember this. So I hope you learned a few things. Keep learning, keep being awesome. Let's just look at the code also immediately, so that we can see that this is indeed true. So we have a uniformly randomly selected point, and let's calculate the variance of that point. That variance is 1 by 3 as we suspected. The function does not look uniform distributed because the data points are quite small, 10,000. Let's change it to 100,000 and a million. And then the function, the frequency function of z, as I said, it is uniform. It's going to look a lot more uniform, as you saw. See, and the PDF is 0.5 as we suspected, right? 1 upon b minus 1 by 2 is 0.5. So that's true. So for a unit circle point, the variance of z is indeed 1 by 3, mean is 0, and it is uniformly distributed. So now we are doing 10 million. So as you can see, this is looking pretty good. So we did a decent job. 0.33333. Okay. So I hope you learned a few things and it was beneficial for you. And I hope you learned all these formulas. Try to remember them and keep learning, keep being awesome. Bye.